9.7, solving quadratic systems. The first thing I need you to do is remember, Brian, would you please sit up? I need you to remember when we did linear systems, when we solved linear systems. When you solved a linear system, you had an equation of two lines, and you came up with a solution. Anybody remember what that solution meant? The point that satisfied both equations. Graphically, do you remember what it meant?
The line cross.
The line cross. So that point that we found was the point of intersection, and that point also satisfied both equations. So now we're going to do the same thing, only we're going to do it involving, we're going to have some lines. We're also going to have all of our quadratic equations. Circles, ellipses, hyperbolas, parabolas. So now first thing I want to do is draw some pictures, because I want you to be able to visualize what's going on. So if I had a circle and a hyperbola on the same graph, and they look something like that, and I solve the system with those two, what would be the solution? No solution, because they don't intersect. So if the two graphs never intersect, that would be no solution. Now, if, let's say I have a parabola and an ellipse, and they look like that.
One solution.
That would be one solution. At one point where they intersect would give me one solution. Okay? Let's see. I have a hyperbola, like so, and a circle, like so. How many solutions is that one? Two solutions. Okay, let's see. Can we get three? I think we can get three.
Maybe. Yeah.
Let's look at a parabola and let's see,
A giant ellipse, right?
an ellipse that touches the vertex there, touches the parabola out here, and out here. It's kind of a sketchy ellipse. But one, two, three. Okay, so that would be three solutions. Now we can do four too. If we had, let's do something different. Let's do a hyperbola and a parabola. There's my hyperbola, my parabola intersects like that. One, two, three. And of course, those are just examples. You can mix and match all your different shapes together and get different ways. But on the problems you're going to work on today, you can have anywhere from 0 to 4 solutions. Okay? Okay, so let's remember substitution. if I have two equations, x squared plus y squared equals 10, by the way, what is that shape?
A circle.
That one is a circle. And my second one is y equals negative 3x plus 10. Well, that's what?
A line.
A line. Because there's no squares, it's got to be a line. So I have three possibilities. One is they could not intersect at all. Two, the line could be tangent to the circle, and they'd have one solution. Or the line could go through the circle, and it'll have two solutions. So those are my three possibilities. So let's do our algebra and see what we come up with. So if you remember substitution, the whole object of substitution is I want to combine the two equations in such a way that I only have one variable.
Make it the top one equal to x.
So, well, I've already got this one equal to y equals this, so I'm going to substitute all of that for my y. So yeah, so it's all going to be an x. That's okay, so I've got x squared plus, now you'll notice it's y squared, so that means all of this is squared. So negative 3x plus 10 in parentheses squared equals 10. Now when you square a binomial, you have to FOIL it. It's not just square the first one, square the second one. Now, if you remember how to do the shortcut, you can use it. I'm going to use the shortcut, remind you about it. If you don't remember that, you better put it on the side and FOIL it out. So I've got x squared plus, okay, the shortcut goes like this. The first term squared, so negative 3x all squared is 9x squared, plus the first term times the second term times 2, so negative 3x times 10 is negative 30x, times 2 is negative 60x, so I need a minus here. 60x. And then the last term squared. So 10 squared is 100, so plus 100. Anybody remember that? Good. You can shorten things up a little bit, life is good. Okay, so now you're going to look at that and you're going to say, oh, that is a quadratic equation. The best way to solve a quadratic equation is you get everything on one side equal to 0, and you factor it if it will factor. So let's see if we can do that. So x squared plus 9x squared is 10x squared. We're going to combine like terms. Minus 60x is just, that's the only x term we have. Plus 100, but I'm going to subtract 10, so I get plus 90 equals 0. Okay, so next thing you do is you look at it and you say, oh, there is a greatest common factor. What is it? 10. So I've got 10 times x squared minus 6x plus 9 equals 0. And now I look at the quadratic part and say, can I factor that? And the answer is yes, indeed. Let's see. This is a plus 9, so they're both minuses. 3 and 3. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. Okay? So, since they're the same, I only have one answer for my x. So x minus 3 equals 0. So x equals 3. Okay, so I have my x value. Now you have to get your y value. So we're going to go back up here. Let's look at the circle equation. And we're going to put the 3 in for the x. So I get 3 squared plus y squared equals 10. So 3 squared is 9. 9 plus y squared equals 10. So y squared equals 1. So y could be plus or minus 1. So it gives me 2 points. It gives me the point 3, 1 and the point now you have to make sure that it solves both of the equations. So let's check 3, 1 in the linear equation. I get, so for the check, I get 1 equals negative 3 times 3 plus 10. So 1 equals negative 3 times 3 is negative 9 plus 10 is 1. That one checks. Okay, so let's look at the second one. Negative 1 equals negative 3 times 3 plus 10. Well, that gives me negative 1 equals 1. Doesn't work.
One solution.
It's got one solution.
Is there any graphing to it?
So we'll deal with that later. Okay? There's a picture of those two. So if you look at it, here's my circle, here's my line. So at 3, 1, that's my point of intersection. Okay? No, I am not going to ask you to graph this. So you might want to do it on your calculator. And actually, we will do some on the calculator. Okay. So let's do a second one of those substitution ones. So what shape is the first one? That's a parabola, because it's got a y squared, but the x isn't squared. What shape is the second one? It's a line, because neither one is squared. So you have an x and a y, but neither one is squared, so it's a line. So a parabola and a line. And we're going to do substitution.
X is equal to y. So y equals negative x.
Y equals negative x. If I'd solve this one for y, you could solve it for x and do it the other way. It doesn't matter, as long as you do one or the other. So I get y squared minus a minus, let's see, equals negative x. Actually, I'm going to do it the other way. X equals negative y, because I want to substitute this one in there. So instead of x, I'm going to use minus y, so it's going to become plus y minus 6 equals 0. And the reason I wanted to pick that one is because when I do that, it comes out really nice already, ready to factor. Got y and a y, and then minus 6, so it's plus and minus. Plus 3 minus 2. So I get two solutions. Y equals negative 3, and y equals 2. Okay? So, let's take that back up here. Let's put it back into our linear equation. So in my linear equation, I get negative 3 plus x equals 0. So x equals 3. So that gives me the point 3, negative 3. And with my other solution, I get 2 plus x equals 0. And x equals negative 2. So I get the point negative 2, not 2. Now, again, you should check them in your other equation, make sure they work. Just in the interest of time, I'm going to tell you that they do. So those are your 2 points of intersection. They both work. They both do. And I'll show you what the picture is for that one. Everybody got this?
Put negative 2 and 2 into the y squared minus x. Yeah.
Yeah.
That'd be 4.
Yep.
Plus. Okay. 4 minus 4 is 9.
So 4
I got
minus
it.
a minus
Yeah.
4. Okay. So, yep, they should both work. Okay, so what it looks like is this. So you've got this point, 3, negative 3, and negative 2. So that's what they would look like graphically. Now I'm going to show you how to graph these on your calculator, so that is a good way to check them as well. Okay? Yes.
Are all the ones we're going to be doing today just a line and
The next one is okay. So the other type of solving linear or was elimination. Now, when you look at this one, it's got some extra stuff in there. So we've got, I'm going to put it so all the x's are together. And don't let that scare you. All that does is tells you that it has a center at some place other than 0, 0, 0, and we're not going to worry about where that is. That's not a problem. What kind of a shape would that be? Let's see if we can figure it out. Let's look at our x squared and our y squared. They're both positive. So it's got to be, they're both squared. So it's either got to be a hyperbola or not a hyperbola. It can't be because it has a negative.
Let's say
Ellipse or a circle.
let's say
And since the 9 and the 1 are different, then it's going to be an ellipse. It is good. Okay, so now let's look at the second one. X squared minus y squared. What is a minus? Hyperbola. Hyperbola. So this one is a hyperbola. Now, when we use elimination, we try to line up like terms. So I'm going to put the x squared under the 9x squared.
plus 0x.
Plus 0x, and I'll just leave a space. So minus y squared minus 16. Now the whole object here again is to get either rid of all the x's or all the y's. This is going to get me rid of my y's if I add both of these together. So I have 9x squared plus x squared is 10x squared minus 90x. Y squared minus y squared is 0.
Plus 2.
So plus 200.
Factor of 10.
Factor out the 10.
Factor 4.
And this will factor. Instead of parentheses, x and an x. Both minuses, and it's going to be a negative 5 and a positive 4. Okay, so that gives me two values for x. Everybody, I kind of did that fast, so anybody that I lost in that? You got it? You okay? Okay, so x minus 5 gives me x equals 5. X minus 4 gives me x equals 4. So I come back here. I'm looking at those two equations. I'm thinking the second one looks a little easier to deal with, so I'm going to start there. So if I put a 5 in for my x squared, I get 5 squared minus y squared minus 16 equals 0. 25 minus y squared minus 16 equals 0. So 25 minus 16 is 9. 9 minus y squared equals 0. So if I add y squared to both sides, I get 9 equals y squared, but I'm going to write it this way. Y squared equals 9.
3.
So y is equal to plus or minus 3. So that gives me 2 points. The point 5, 3, and the point 5, negative 3. Okay, now let's look at our other one. Let's look at our 4. We're going to do this one, put it into that equation. So I've got 4 squared minus y squared minus 16 equals 0. 16 minus y squared minus 16 equals 0. 16 minus 16 is 0. So negative y squared equals 0. So that means that just y squared equals 0. So y has to be 0. So that gives me one more point. It gives me the point 4, 0. And again, you should check. I'm going to tell you all 3 of those are going to work. And I got a picture for that one. Everybody got these? Okay. That's what it looks like. The green one is our hyperbola. Here's our ellipse. It intersects in 1, 2, 3 points. And those are the ones we found. Okay. Okay, so that's substitution. substitution and elimination. You can also do this on your calculator. So, get out your calculator. Let's see how you guys do. Third period did a little bit better than first period. So that means you guys are going to just nail it right off the bat. Okay. So, using your calculator, I have this system. Y squared minus 7x plus 3 equals 0, and 2x minus y equals 3. First thing you do is you take each of your equations and you solve them for y. So if I add y to both sides and subtract 3 from both sides, I get y equals 2x minus 3. Okay?
7x minus 3.
Now, that one's going to be a little trickier.
Square root.
So you're going to put this one in the y1. Now, let's look at the second one. When you have a y squared, it gets a little bit tricky because when I solve for y, so let's look at this one down here. So I get y squared equals 7x minus 3. Well, I want just y because I can't enter y squared in my calculator.
Square root of 7.
So y equals, now I have to consider both the positive and the negative of the square root of 7x minus 3. Now, so you're going to put it in two different places. So y2 is going to be just the square root of 7x minus 3. And y3 is going to be the little minus sign, not the minus, but the little negative sign in front of the square root of 7x minus 3.
And
then hit graph. You should get a sideways parabola intersected by a line.
Yeah.
But you not get that. Got it. Just right. Yeah.
So I went to the left
It's kind of like that. Go to second step.
No. Yeah. Well, okay, so we got a little line, and then it was like.
Okay? Let me see yours. I want to see on calculator.
And then it's right.
Yeah, that'll do in today's assignment.
See the calculator you got? I got it.
But every time I do when I graph it, it goes.
Okay. I'll do your
Wonder if she
way.
knows if she's still recording. Yeah.
Freddie's so cute. Oh my god.
I'll have to go back.
Oh, Courtney, stop saying that.
Okay, so you put it in your y equals. Everybody, well, most of you got that done. And next, you're going to say second trace. And under second trace, you're going to choose intersect. Now, when you press intersect, it's going to ask you first term. And if you look up at the top, it'll say y1, y2, y3, one of those. And whichever one is, in the first time you do it, it doesn't really matter which one comes first. Most of the time it'll give you y1. If you want to change that, use the up and down arrows. It'll change it between the toggle between the three. Okay? And then push in. And it'll say second curve. And just so we're all kind of on the same page, let's choose y2. And say enter. Now,
The 100%.
I can tell you why. Okay. picture looks something like, let's see, your line's going this way, right?
No.
This way.
Yeah.
There we go. Something like that? Okay. So if it won't let you push enter, make sure that your cursor is somewhere in the vicinity of that intersection point. Your cursor, you can move it with the left and right buttons. Okay, you got it. So then, make sure it'll say guess. Make sure that your cursor is close to that intersection point and push enter. And it should tell you 4, 5. And to get the second intersection point, you are going to go through this whole process again. Second trace, intersect, Y1. This time you're going to choose Y2, or no, I'm sorry, Y3, and make sure that your cursor is close to the second intersection point. And when you say guess the second time, it should come out. I have this written down somewhere. Oh, here it is. It's a decimal this time. Yes. 0.75, and what was the other one? Negative 1.5. I'm going to have you round to the nearest hundredth if you need to round. So 2 decimal places if you need to round.